Hi guys, and welcome to my channel. First time using this screen recording stuff, but we'll give it a shot, see how we go. I just wanted to go over a video that Keelan made from Sarah and Keelan's Adventures or Travels or whatever they're called. And the reason I want to go over it is because I own a caravan repair business that specialises in off-grid systems and we've been doing this for just on 23 years now, so I want to go over this video because it makes things a little harder for us. Excuse me, when people come in and say, well, I've seen this video on YouTube and he said this and he said that, and makes it harder for us because we've got to explain as to why that's wrong, and advise the customer as to which way would be the best way for them to go. So without further ado, we'll jump into the video. I've broken his video up into little bits and pieces, so we can go through each section and correct all the wrongs that are in the video.
What pisses me off the most is these companies making so much money and misleading people, selling them dreams that are just never going to come true. It's an absolute scam. Whether these companies know they're misleading people or they're just not educated on the topics, today we are going to discuss all of that, and we are talking about the hottest topic in the industry at the moment, and that is a 12 volt system as good as a 24 or a 48 volt system?
Okay, so there's nothing wrong with a 12 volt system. We install plenty of them. However, a 24 volt system is far better in the way of efficiency, and it is no more difficult to make a 24 volt system than it is to make a 12 volt system, and it is no more expensive. In a lot of cases it's actually cheaper. So a 24 volt system is definitely better than a 12 volt system, and we'll see why as we go through each part of the video. Okay, so let's move on to the next bit of the video and we'll go through that as well.
My name is Keelan. I'm a qualified electrician. I'm qualified to make this video, and the idea is to educate and give you guys the tools to make the right decisions for yourselves to hopefully save you some hard-earned dosh, some cash, and hopefully some tears, so you can make the right call on what you guys actually need. Be careful though, I'm qualified, but doesn't mean that everyone on YouTube is. Anyone can grab a camera and make a video like this claiming to be a guru. I've got the qualifications to show for it, and I'm obsessed with this stuff.
Okay, so he's a qualified electrician, and like he said, anyone can grab a camera, make a video and claim to be a guru and chuck it up on YouTube, which is what we deal with all the time. So the first thing I'll say is that being a qualified electrician in no way, shape or form qualifies you in the area of ELV DC systems, which is extra low voltage DC systems. Totally different kettle of fish. Electricians deal more with AC and voltages of 230 and upwards, and very rarely have anything to do with low voltage DC systems, which we are talking about here. Alright, so let's move on to the next part of his video and we'll see what he has to say.
The next little thing, little piece of bullshit that I hear, and I'm sorry for swearing a lot, I'm very passionate about this, but is this system here is going to outlast this system here. Now, that is, majority of that statement is not true, and I'm about to show you why. So, say we have an air conditioner, and everyone loves talking about how long they can run their air conditioners for off-grid. So, let's make this really simple. We've got 2,000 watt air cons. They're pulling 2,000 watts. On this one, they're pulling 2,000 watts at 24 volts. And on this one, they're pulling 2,000 watts at 12 volts, right? So in this equation, if we do 2,000 divided by 12 volts, we're going to get 166 amps. Okay, that's what the aircon is going to be pulling when it's cycling down. It's ramping up. It's trying to make your caravan as cold as possible. It's going to draw this much power off your batteries. in this equation, we do 2000 divided by 24, it's only going to be drawing 83 amps, right? So you're probably thinking, that's an 8 by the way. So you're probably thinking, Keelan, this one is going to outlast because that's only drawing 83 amps, where this is drawing 166 amps. You're wrong. Let's go back to the original point. By paralleling our batteries here, we're getting a 250 amp hour capacity. So this ratio here, 250 to 166, is the exact same that 83 amps pulling off 125 amp hour batteries, meaning these will pretty much run out of battery at the exact same time.
Okay, so that's not entirely true. We have found that when you step up to a 24 volt system running the same loads, you get about an extra 12 to 15% runtime on the same load. And that's due to resistive losses in the system. So we'll just have a look here. We've got our old Ohm's law calculator up, and this is just so you can see what I'm talking about. So if we have a 12 volt system, we've got our cables running from our battery bank to our inverter, and let's say the inverter's got a load of it that requires 50 amps from our batteries to that inverter of current flow. And let's say that of course with this setup we'll use conventional current flow here. So the current's going to flow out of the positive, run through your cable into the inverter, through all the primary side inverter workings, and then back out of the inverter through another cable back to the negative side of your battery. So let's say we've got just 0.1 ohm, oh, doesn't go there, 0.1 ohm of resistance through all those cables and internals of the primary side of the inverter. So the power dissipated by the cables and the inverter on the primary side, it's going to be about 250 watts. Now most people make the mistake of thinking that when we double the voltage, of course we halve the current, that our losses are going to be halved as well. But hang on, I'm going to have to reset that. So we halve our current because we double our voltage. Our resistance remains the same at 0.1 ohm, and if we calculate that, we can see now our losses in the cables and the primary side of the inverter is only 62.5 watts. So we've reduced it by 75%, not half as most people would think you would do, and that's just Ohm's law. So that's where the extra 12 to 15% runtime comes from in this particular case, is because we have reduced our resistive losses through the cables and the primary side of the inverter by 75%, not 50. So something to keep in mind. Alright, so on with the next bit.
So let's draw an inverter into the situation right here. So that's an inverter, this is an inverter. Okay, this one here is going to be doing 12 volts to 240 volts. So 12 to 240. This one is doing only 24 to 240. This air conditioner, this inverter here is having to step up 12 volts 20 times. So let's talk about how much work the inverter is doing. So this is doing 20 times the work to transform 12 to 240. So 12 times 20 is 240. On this side, because this is double the voltage of this system, this air conditioner is only doing 10 times the amount of work to step 240 into 24 into 240. And by saying that, your inverter is actually going to be a lot smaller because the internals can be smaller. It's doing less work, so it requires less beefy componentry internally.
Okay, so that's not true either. Both battery banks have to deliver the same amount of power to the inverter to drive the same load on the output of the inverter. So while the amps might be double here, the voltage is only 12, where the amps are halved here and the voltage is 24. Both scenarios, each battery bank is delivering the same amount of power, which is watts, to the inverter to drive the same load on the output of the inverter. And inverters, 12 and 24 volt inverters, are mostly the same size. The only thing that changes is the amount of windings on the step-up transformer, where the 24 volt inverter will have twice as many windings as the 12 volt inverter on the primary side of the step-up transformer within the inverter. And then you get your switch mode inverters, which I wouldn't touch, so we definitely don't want them. We just want a nice big beefy step-up transformer, which does have a switch mode supply to that step-up transformer, but it's not a dedicated switch mode transformer. It uses a or switch mode inverter that uses a step-up transformer. So no, both battery banks are doing the same amount of work, and both primary sides of the inverter are doing the same amount of work to deliver the same output power to the load. Okay, let's have a look at the next bit.
This inverter is going to be a lot harder to find than this inverter. They are becoming more common. However, that inverter to replace is going to be harder to replace than this one here.
Okay, once again, simply not true. 24 volt inverter is just as easy to find as a 12 volt inverter. All the reputable brands like Victron, Energy, all that make 24 volt inverters just as much as they make 12 volt inverters. Our trucking industry, which is mostly 24 volts, has been around for many years, and so are the inverters for those 24 volt systems on trucks. So you can jump on eBay and you can order a 24 volt inverter to be delivered to you free of charge just as easily as you can order a 12 volt inverter. So that is also not true. Okay, so on with the next bit.
And let's talk about something that no one tells you. So you've saved a bit of money here, but it's about to disappear. So on a conventional caravan system, you have things like lights, fridges, things that run off 12 volts. Now the simplicity of this system is beautiful. Out of the battery, normally you go through some fusing into, say, a switch to turn the appliance on or whatever. That switch closes, put power into your appliance. And normally all the appliances very commonly are 12 volts. Now, if we have 12 volt appliances down here, you're probably going to say to me, Keelan, 24 volts into a 12 volt appliance is going to blow the shit out of it. And you are correct. So you've got two options, right? Your first option, and this is the most common option if you spec a caravan to 24 volts, the manufacturer is going to run all of your loads, 12 volt loads, through a converter. So what a converter does is transforms the 24 volts into 12 volts, which is safe for your appliances to use. And remember, going back to the point where I said you just saved 150 bucks on your inverter. Well, you've just spent 150 bucks on your converter. Okay, so this costs money. Basically, you're going to consume some of this, if not all of this, in putting one of these in, where you could keep it simple and just have 12 volts going into 12 volt appliances. Okay.
Okay, so as Keelan would say, that is more bullshit. And one of the reasons that being a qualified electrician doesn't qualify you in low voltage DC systems. Every compressor fridge I know of, whether it be a large one inside a caravan, your little one you chuck in the back here or ute and go off for a day's fishing, are all 24 volt DC. They are more efficient on 24 volts than they are on 12 volts, as we've seen before. And your ones like in your caravan, the big uprights, are also 240 volts. So fridges are 24 volts. Every one I have seen, I've never seen a dedicated 12 volt compressor fridge. As far as your three-way fridges go, still not a problem. They're either 240 volts gas or 12 volts, but they get their 12 volt supply from the vehicle, not from your house batteries. So that's how they are. There's your fridge is not a dedicated 12 volt fridge. It is 12 volts, 24 volts compatible, run better on 24 volts, more efficient. Lights, most modern caravans have LED lights that are 12, 24 volts. If not, what's it going to cost to replace, say, 10 light globes in your caravan? 50 bucks? Yeah, well, there you go. And they're just as available as a 12 volt light globe. The only thing you may have to change, let's say your light globes, that's 50 bucks. Even your water pumps in most modern caravans are 12, 24 volt compatible. They work much better on 24 volts, more efficient, more flow rate. So another win there. Even your Sirocco fans, they're 12, 24 volt compatible. If you don't have a 24 volt compatible water pump, that's going to cost you $100, $150 to replace. So, you know, we would never use a converter in a off-grid system. We would simply change the very few things we have to change, like maybe some light bulbs in older caravans, and people want to step up to LEDs anyway. They're more efficient, and 24 volt LEDs are more efficient than 12 volt LEDs, simply because you incur less losses in the cabling. So yep, that's that dismissed, and we'll move on to the next portion of the video.
Or luxury caravans such as Urban, I know that Urban for a fact, these guys actually get their hands on 24 volt appliances. So you don't need a converter anymore. However, this is a lot more rare and more expensive to get your hands on than a 12 volt appliance. A 12 volt light is, you know, there's dime a dozen, you know, but this will be more expensive, harder to get your hands on. If something ever happened to this appliance, very, very difficult to get your hands on, especially if you're up at Cape York. So this is a bit of an issue when it comes to 24 volt systems.
So as we discussed just a minute ago, totally wrong. 24 volt appliances are just as easy to get as 12 volt appliances. Your fridge, you don't have to worry about, it's already 24 volts. Your three-way fridge runs off your vehicle, not your house batteries. Don't have to worry about that, don't have to change that. There's nothing you can't get in 12 volts that you can't get in 24 volts, just as easily, just as cheap. So just wrong. Okay, so let's move on to the next bit.
The next thing that I'm going to talk about, so far we've only shown the electricity going that way, but you're probably wondering, Keelan, where is my solar, where is my alternator, how does that all work with the different systems? Explain that to me. So that's what I'm going to do now. So in the same situation, we've got, let's do the alternator first. Let's talk about that. So in Australia in particular, we have a lot of rainy days as much as we have sunny days, depending on where you are in the country. So alternator charge from your car. So actually, I'm not going to draw a car. I'm not the best at drawing cars. So anyway, I've just put an A there for alternator. Your alternator, at best, I've seen my alternator pump out 13.7 volts. And that's when it's nice and cool. That's as much as you're probably going to get out of an alternator in Australia. Volts, not amps. Yeah. 13.7. Normally you run that through your DC to DC charger. DC to DC charger, and for this one, it's going to be a 12 volt DC to DC charger. Say mine in particular 60 amps. Alright, so you've got 13.7 volts coming in. Normally a DC to DC charger will pump that up to like maybe 14.4 volts at best. So that's like when the algorithm is demanding like a bulk charge in your battery system. With this instance, we've got 13.7 volts, and you're probably saying to me, 13.7 volts, Keelan, cannot charge a 24 volt system. The voltage is simply not high enough to actually charge the cells in this battery. And you're 100% correct. So this does not work at all. However, it can work. And that is by introducing a specialty piece of equipment that actually goes from 12 volts to 24 volts. Now, this is specialty. This is a lot harder to find. It's the same to wire. You have two tails coming in, two tails coming out, than this, and harder to find. So again, like I said with the 12 volt loads, we're having to introduce pieces of equipment in where normally they wouldn't even be required in a 12 volt system, just purely to make a 24 volt system practical and functional. So before I said they have to put a converter in to be able to transform 24 to 12 volts to be able to, your appliances to be able to cope with it. Now we're actually introducing another piece of equipment. I guess you normally would have a DC to DC charger, and the issue is with this, without getting too testicle with it as well, is that this can produce backfeeding issues, and then you have to introduce diodes, and I could go on and on about the potential issues that this could cause to your system. I've never done this as well. I'm just thinking of the potential issues that could arise. So you could actually have to introduce even more equipment into this to make this work, like isolators or a diode or some sort of electrical gate to stop backfeeding.
Okay, so a classic example. Well, a qualified electrician is not qualified in these low voltage off-grid systems. I have no idea what he's talking about when this is a specialty part. It's going to need blocking diodes and all sorts of stuff. That's simply not true. These are an off-the-shelf part. They're just a DC-DC charger. Victron make them, Energy make them, I think Enerdrive make them, and it's simply nothing special about it. Costs no more than this, and it's just a DC-DC charger. With this one might step the voltage up to around 14.4. This will step it up, well, the Victron one, anything up to 30 volts from 12 volts, whatever you set it to be to suit your batteries, and it can all be done on your phone, simple as, because it's all Bluetooth compatible being Victron. So yeah, once again, there's nothing special about it. It's just a DC-DC charger that can be bought off the shelf. Okay, let's see what he's got to say now.
That's this side. Let's talk a little bit about the solar, because solar is the biggest thing in my opinion, and you guys know that I harp on about solar. So let's talk a little bit about the solar side of things as well. Okay, here we go. So essentially we're going to draw some solar panels over here. Both systems require solar panels. Now, the same reason that the alternator couldn't charge this 24 volt system, and it's easily going to be able to charge a 12 volt system, the same principle will apply with solar panels. So for a 12 volt system, generally speaking, we run 24 volt panels. That's very generic. That's the generic way of doing it. You can have 48 volt, even up to towards 100 volt panels, and going through a step down MPPT charger. However, generally speaking, this is what you'll find most times. So to be able to charge a 24 volt battery bank, we're going to have a higher nominal voltage of our solar panels. That means our solar panels can be 36, but the most standard would be a 48 volt panel. Now, these 48 volt panels obviously are feeding, mind that arrow, feeding electricity in. Normally, generically, we would have a solar controller. Now that would be in the form, my favorite is MPPT, so max power point tracking solar controller. You can get PWM, so pulse width modulating controllers. I really like this one for big solar arrays. So we've got our MPPTs here. And for this particular setup, we're gonna have a 24 volt MPPT, mind that. And in this situation, it's gonna be a 48 volt MPPT. Now, if you were to ask me, Keelan, and this is before I get into the advantages of all this too, because I know a few of you are sitting on the couches with bated breath, waiting for me to talk about the advantages of this, and trust me, they're coming. However, if you were to ask me, Keelan, which system would you like to work on out of these two? I would say it is way safer to work on this system than this system. This is a lot more dangerous. As soon as you up the voltage, you are creating danger. Now, what's deemed safe, anything under 30 volts. And for the average Joe Blow, I would deem this system unsafe to be able to work on. So that is another thing. If something happens out in the bush and you need your stuff to work and work properly, you can't go and fault find because it's deemed dangerous. By upping the voltage on your solar panels, you're adding danger.
Okay, so that's the biggest load of garbage I've ever heard. The Australian New Zealand Electrical Safety Commission deems it safe for any competent person to wire up a DC system to a voltage of 120 volts ripple free. That is what the experts deem safe. 48 volts is absolutely nothing when it comes to DC, and it's perfectly safe. So that's just utter rubbish. I don't know where he came up with the 30 volts. I'm thinking he's trying to push his 12 volt system and throwing in some disinformation. But yes, the electrical regulation body deems 120 volts safe, up to 120 volts safe, that any competent person can wire up without a license. So if we're talking 48 volts of solar panels, then you're perfectly safe. It's not going to hurt you in any way. And in saying that, in regards to solar panels, if you're going to have 6 solar panels on the roof of your caravan, we would wire 3 lots of 2 into series, and then we would wire those 3 series connected panels into parallel to keep the current down and the voltage up, and reduce resistive losses in the solar side of the system. As far as these DC to DC converters, solar charge controllers go, I don't know what he's talking about, 24 volts and 48 volts solar charge controllers here. Most decent solar charges controllers these days, like the Victron 5100, will take up to 100 volts input. These would be exactly the same charge controller, no different whatsoever between the two. They are the same. You could put that charge controller here or here. So yeah, that was a bit of rubbish. Okay, so let's keep on keeping on here.
I'll get into the positives in a minute, but I really wanted to touch on that danger. And like I said at the start, we are talking about 24 volt systems, but the same things apply to 48 volt. If you have a 48 volt system, I'd rather work on a 24 volt system, if not a 12 volt system. You can put your tongue on this. Yes, it's gonna hurt like hell. You put your tongue on this, it's gonna freaking near on kill you, rip your tongue off.
Okay, so how many out there go around sticking their tongue on the battery to make sure it's got charge? I mean, it's bordering on ridiculous now. I'm pretty sure heavy duty diesel mechanics, when they're working on a 24 volt truck system, don't go and stick their tongue on the battery to see if it's got any charge. I wouldn't think anyone would do that. Okay, on with the next bit of the comedy show.
One thing that I'll touch on before I raise all this is the simplicity factor. So a massive disadvantage, so I should say a massive advantage of the 12 volt system is it's incredibly simple. So
okay, so the 24 volt system is just as simple. There is no difference between the two, other than the batteries are series connected in the 24 volts systems and parallel connected in the 12. Everything you use is identical. So not sure what he's talking about there. Okay, so I guess it's time to move on to our next bit of the comedy show.
Increasing your voltage, you're actually going to retain, you know, this is a volt drop of almost, that's the whole volt drop, which is huge. Where here we might get to the end point and still be at 23.8 volts, you know. So that is a lot less losses. There's less eddy currents. There's less.
Okay, I think he's in AC mode. Eddy currents in DC. Okay, so eddy currents are created by changing magnetic fields. In a DC system, we have no changing magnetic fields. That's why it's called direct current. So another example of the qualifications at play there. Alrighty, so we'll move on to the next bit. We're getting close to the end.
Only doing 10 times half the amount of work. So that is another one, and that goes back to that efficiencies. So And when I talk about all this, efficiencies is the biggest difference between 24 volt systems and 48 volt systems and 12 volt systems. You're just gaining the efficiency.
Okay, so you remember towards the start of the video, he said that the 24 volt and 12 volt system would drive the aircon for the same amount of time, and now he's here actually admitting that the 24 volt system is more efficient than the 12 volt system, and that's just how it is. They are. Alrighty then, we're on to the next bit. We're getting close to the end.
For all the headaches, all the extra converters, you know, your alternator's not going to work, the higher voltage, it's more dangerous, all these different factors, do I think this result is worth it?
Well, I don't know what he's talking about there. As we've seen, there's no extra anything in a 24 volt system. You have the same amount of components, only that the 24 volt system is more efficient. So yeah, don't know what he's talking about there with all these extra components. There simply is none. Okay, so on with the final bit of the video, and this is going to be the best bit, and then we're going to go and design and buy all the parts for our off-grid system and see what happens.
The reason I think that is because in our caravan, last caravan, we bought a very affordable system from iTech World. It cost us about $6,000, which in comparison sounds like a lot of money, but a 24 volt system, say from Victron, might cost you 40 grand.
Okay, so you remember at the start of the video he was talking about companies deceiving and ripping people off. So I just want to go back here a little bit. I want you to have a look at this. Normally $18,270 for this system here, slashed to $8,524, saving you $9,746. I can tell you now that this average quality system was never ever worth $18,270. So sometimes you got to be careful what you say and what you post, because if that is not misleading, I do not know what is. Also, did you catch this little bit here?
But a 24 volt system, say from Victron, might cost you 40 grand. And the reason I think that is because in our
$40,000 for a 24 volt Victron system. Okay, so let's put that to the test. Where was it again? What's our budget? $8,524. We get an inverter, two charge controllers, which means double the wiring on your solar side. What do we got? 2, 4, 6, 8 panels. What's that? 150 watts each, so we've got 1200 watts of panels. We've got 4 240 amp hour batteries, and we've got a couple of monitors here, one for the inverter and one for the solar. So let's go and put this $40,000 Victron system together, shall we? And we'll see what happens. Okay, so it's time to go and build this $40,000 Victron system. So let's get into it. Today's prices as is right now, and what we can get a Victron system for. So the only thing I won't be using that is Victron is their batteries. They are too expensive for what they are, and you need an external BMS with some of them, or most of them should I say. So that's another cost added on top of the batteries. But here's our budget, $8,524. We get one inverter, 2 charge controllers, like I said, so double the wiring for the solar, 8 solar panels. They are 150 watts each. The solar and inverter panel, which we also have to wire up, and 4 240 amp hour batteries. So That gives us 12.28 kilowatt hours of battery capacity. Alright, so let's go and build our system. We'll get rid of that. So once again, that's our budget. Keelan says $40,000 for a Victron system. Let's build it. Today's prices on eBay, shipped to your door. So there you go. So we're going to use the best of the best in the Victron gear. A 24 volt 3000 VA multi plus that has the built-in battery charger. I think it's 80 amps, 75 to 80 amp battery charger, more than enough for our battery bank. So the price for that is $2,030.19, free shipping. So once again, $2,030.19 for the multi plus 24 volt, all off the shelf items. Our next item we're going to look at is our 5100. So that's the solar charge controller. That will do 12 and 24 volt systems. They are identical chargers. So as you can see, we don't need a different solar charge controller. At 24 volts, this will charge a 24 volt battery bank with a slightly higher capacity than the two charge controllers that you get with the iTech World kit. So they give you two 40 amp ones for 12 volts. We give you one 50 amp one for 24 volts. If we grab our calculator here, so 24 volts times 50 amps, we get 1200 watts. If we clear that, our 240 amps is 80 amps in with our 240 amp charge controllers, times our 12 volts is 960 watts max. So this is a better option than the two on 12 volts. $219.39. These always, Victron always has specials, so that's just the price I use, and once again, free shipping. Next thing we'll look at is the solar panels. Now we're going for, these are 185 watt panels, and the Victron solar panels 185 watts. So we're going to be needing what was it, can't remember how many they had. I think it was 8. So 8 at 185 watts. That is of course more than the 8 at 150 watts each you get with the iTech World kit. So 2 8s are 16, so about $1,600 for the solar panels, and we're going to have more solar power, of course, with these panels being 185 watts each. Okay, for our batteries, which is all we've got left, I'm going to use the brand new latest and greatest technology from Renogy. That is good gear. We're going to have 4 of them at $1,199 each. So the batteries being the biggest cost, $4,796 for our 4 batteries, but these are 300 amp hours. So instead of our 12.6 kilowatt hours, was it, from the iTech World kit, we're going to have over 15 kilowatt hours with these batteries. So if we add all that up, our total is $8,662, and our budget and the iTech kit was $8,524. Now don't forget, we are using top of the wazza Victron gear, except for the batteries, which are also top of the wazza. We have 3 odd kilowatt hours more battery capacity in this kit, and we have more solar capacity with this kit than the iTech World kit. and we're paying an extra what, $130. So God knows where he got $40,000 from, but we just done a Victron kit, the same as what you get with the iTech kit, for 8,662. Once again, the iTech World one was 8,524. So you make the decision on what you're going to buy. An average quality bit of or an average quality system, or a top end system for an extra $130 odd. Now, no DC to DC charger in the iTech World kit, and no DC to DC charger in this kit, but here is the off-the-shelf DC DC charger you would use. Sarah and T-Smart 122400-15, that means 15 amps at 24 volts, which is equivalent to 30 amps at 12 volts. So that would do you just fine to give your batteries a bit of a charge up while you're driving along. $299.20. Like I said, Victron gear is always on special. You can always get it cheaper. So these are the prices I use for what I could buy it for today. So whack on an extra $300, let's say, and you have the DC-DC charger, which doesn't need reverse blocking diodes or anything like that. It's just a DC to DC charger that'll charge a 24 volt system from a 12 volt supply, being your vehicle, of course, at the equivalent of 30 amps at 12 volts. And it's off the shelf. Renogy also make one, and I believe Inverter also make one, but there's nothing special about them. They're just a DC-DC charger that, instead of stepping the voltage up to 14.4 odd volts, that steps it up to about 28.8 volts. Of course, all Victron's gear is all Bluetooth. This here you can either use as a power supply with your phone. You can change, or your phone, tablet, anything that's got Bluetooth. You can change the parameters in this. You can select the charging voltage that you want to suit your batteries down to 0.1 of a volt. Everything in it is programmable. So is the smart solar, which is this, of course, our solar charge controller, all programmable to whatever amps you want to put into your batteries, up to 50 amps. Now here's something for you, this very charge controller, and I'll show you. We definitely have enough capacity in our solar panels. So maximum's 50 amps, and so 50 amps at 13 volts, which is normally the voltage for a lithium battery. The maximum amount of power that can put into your batteries is 650 watts. If you had a 24 volt system, which we'll put down as 26 because we use 13, so we'll double it. The maximum power you can put into your batteries with this very same charger on 24 volts is 1300 watts, and it's just one of the reasons a 24 volt system is far better than a 12 volt system. You keep the same current, double the voltage, double the power going into your batteries with the same controller. So there you go. As I said, being a qualified electrician certainly doesn't qualify you to make a video on 12-24 volt off-grid systems. Totally different kettle of fish, and it pays to do your homework before you go making a video. As you've seen here, we just built a big Victron system, and if we include the DC-DC charger, this magic little number here, that's not the DC-DC charger, sorry, it's this little magic box here, which is your DC-DC charger. You can see that there's no extra parts needed for a 24 volt off-grid system, and if you have to replace the light globes, we can have a quick look here. Let's see, 24 volt LEDs, Now most caravans these days, the later model ones, use the T10. You can buy 24 volt strip lights, they're mostly 12-24 volts. Whatever you like, whatever you can get in 12 volts, you can get in 24 volts. You can buy them by bulk. What we should have done is put LED RV globe. That might get us somewhere faster, just in case you can buy all different types. But mostly all your LED 12 volt globes are 12-24, like this is 12-24. These are 24, they're 24. Everything's available in 24 volts that you can get in 12 volts. So here's your T10 globes. Most of your latest model caravans have these. 10 pieces for 20 bucks. So what's it going to cost you to chuck some new globes in your caravan? And as I said, a water pump, if yours is not 24 volt compatible, is 100-150 bucks. Everything's free, delivered to your door. So there you have it. These are good batteries, and they're small, compact, latest cells. So we've just built a larger capacity system with a larger solar array for about $130 odd more than the iTech World system. Nowhere near 40,000. So like I said, pays to do your own research, not listen to the gurus on YouTube. And that is why I went through, made this video long. We went through and we bought everything. We didn't actually buy it, but we went through and had a look at today's prices, what you can get it for. Everything is Bluetooth with the Victron gear. You can change the parameters of all the Victron equipment to whatever suits you. And like I said, more battery capacity, more solar capacity for 130 bucks more. And we chucked in our I'll close the page now, but we chucked in our DC controller for an extra 300 bucks. So there you go, less than $1,000 more. You can have a far better system, top of the water system, using Victron gear with Renogy mini core batteries. Alright, thanks for watching guys, and I hope that helps you out. Don't believe everything you watch on YouTube, and be very wary when someone gets on there and says I'm qualified to make this video.